Hello everyone, welcome to this video. In this video, we'll be talking about the center of a group. So what is the center of a group? We may denote it by Z of G. G represents the given group. So center of a group G, that is the subset of the elements of G having some property. Now what is that particular property? So let's have a look. So those elements that commutes with every element of the group G, they come under this set. So we are collecting all those elements which commute with each element of the given group G, right? Symbolically we may write this as Z of G, that represents the center of the group G, right? It contains all the elements A from the group G such that A commutes with all the elements X of G, right? This is what we have written. So if X represents any arbitrary element, so we have AX is equal to XA, which represents the commutativity. So here you see that we are using this notation Zentrum. So what does this tell us? And from where does it come from? The notation ZG, that comes from the fact that we use a German word for center and that represents Zentrum. So that is why we are using the symbol Z of G, and it was given by J.A.D. Senguer in 1904, right? So how can we calculate the center of some group? Let's see it through an example. So we are taking the example of dihedral group D4, right? So for this group, we know this group forms the symmetries of square, and we already know the elements of this. So we have rotation by 0 degree, by 90 degree, 180, 270, horizontal flip, vertical flip, then diagonal flip, and the other diagonal flip, right? And so these are the elements here for this particular group, right? So we need to calculate what is the center of this group. So we need to calculate all those elements which commute with every element of this group. So I have listed down that R0 commute with every element of the group and R180 commute with every element of the group. Now you must be thinking how this thing is true. You may even say that okay, R0 would commute with every element. Why? Because you know R0 was the identity of this particular group. So whenever you write any other element of this group, so it will definitely commute with that particular element. Okay, so we are okay with this thing. But what about R180? Does it also commute with all the elements of this group? So we have to verify this thing. So let's let's move forward and see whether this commute with every element of the group or not. For that, if you remember, we have written down the Cayley table for dihedral group, right? It was given like this. So you know how to obtain this table. I've shown this in the previous videos. You could watch over there if you do not remember. Okay, so once you have this Cayley table, now we wanted to see the commutativity of R80. So let's see it with all the elements. So R180 with R0, that R0 being the identity, it will give you the answer as R180 only, right? So both of them, they are equal. However, we may see this through the Cayley table. So 180 composition, its composition with R0. So we have 180 here, its composition with R0. So and the answer is R180, right? And we may see it other way around, R0 composition with R180, it is also R180. So you see both of them match, so that means we have the commutativity here with R0. So let's see it with other elements as well. For the commutativity of R180 with R90, let's see what do we have. So we have 180 here and R90 here, so this is the answer. And moreover, we have R90 here, its composition with R180, that is also 270. So you see both of them, they are equal to each other, so therefore we have the commutativity in this case with R90. So that means this second step is okay. For the third step, we wanted to see if R180 with R270, is it equal to R270 and R180? So that means both of them should give us the same answer. So let's see this thing in the table. So R180 together with R270, that is equal to R90, and R270 with R180, that is equal to R90. Again, both of them, they are equal, so therefore we have commutativity here in this case also. For the next case, we wanted to check the commutativity. So we have it in all the four cases here. So let's check it with H. So R180, is it commutative with H or not? So we have to see R180 with H. So R180 is here, H is here, so that means the answer is equal to V. What about H with R80? So H is here, 180 is here, so you see the element is V. So both of them, they are equal, so that means we have commutativity in this case as well. So this is true, the answer is V, right? Next, let us see the commutativity of R180 with V, right? So R180 is here and V is here, so the answer is H. And what about the commutativity of V? What about V composition with R180? It is also equal to H. So you see both of them, they are equal to each other. So therefore commutativity exists in this case as well, right? What about its commutativity with D? So R180 is here, D is here, so your answer is equal to D dash. And the other way around, the composition of D with R180, it is also equal to D dash. So you see both the answers, they are the same, right? So that means these R180 commutes with D, right? So lastly, we have to see it with D dash. So R180 is here, D dash is here, so the answer is equal to D. And the other way around, it is D dash is here, right? R180 is here, D dash is here, R180 is here, so the answer is D. So you see we have the answer as D in both the cases. So therefore we have the commutativity of R180 with D dash as well, right? So once we have the commutativity with all the elements, so we may say that this R180 that commutes with all the elements of the group D4, so that means it would come under the center of the group D4. So therefore the center of group D4 that contains two elements, one is the identity element and other one is the R180 degree, right? And moreover, you see identity element would come in the center of each of the groups. So that means the center of every group that is always non-empty, because we would always have one element as identity. There could be more element as well, but identity would surely be there because this commutes with all the element of the group. So that is it for this video. Thank you for watching.